So this is Bob. We'll wait just a couple of minutes for people to join. Rose, I assume you can hear me. Is that correct?
Yep. Yep, we can hear you.
Okay.
I can see your slides too. Yep.
Good. Okay, we'll plan on waiting until the number of people to join, the join rate drops. All right, we seem to be there. Is Evelyn on?
I'm here, Bob.
You want to kick us off?
Sure. Okay, lots of folks. All right, welcome everyone. Thank you so much for joining us today. We're excited to offer our first introduction to FHIR to our Executive Committee and Strategic Advisory Committee members. We know we have been, Bob's been doing a tremendous job going through the FHIR IG work as we move forward in our Gravity project. But we appreciate that sometimes we take a step back and start with the basics. So for today, Bob has volunteered to go through an introduction to FHIR. For those that are new to FHIR or just know enough but don't know the details, and then he will have a second session for this week scheduled on reading the FHIR implementation guide, especially as now he goes through and gives you updates as part of our regular meetings. So excited to have you all here and for Bob offering his time to walk through this. So thank you, everyone. Bob, I'll hand it over to you.
Okay, Evelyn, thank you very much. It's reasonably appropriate that we're doing it this week. This is also the week when we're doing the Connect-a-thon. And we had roughly 27 people on our Connect-a-thon call track this morning. The numbers vary depending upon who brought code to test or who wanted to go and participate in which portion of it. But I think we've had very good turnout. As Evelyn said, what we're going to do for the next 55 minutes is go through an introduction to FHIR. What is it? How did it get created? What do we use it for? So we'll walk through that. We'll also show you how to go and access FHIR-based resources on the HL7 website. So let me start by doing this. We'll do a couple of things. We'll do the basics. We'll talk about what resources and references are. We'll talk about structured data. We'll talk about profiling, which is the way we constrain down FHIR to meet a particular use case. And we'll talk about some of the exchange paradigms. A number of these slides were created by David Hay and organized by Viet and myself. And this is licensed under Creative Commons, so it's available for anyone to use. Why interoperability? Health information sharing is becoming increasingly important. It's important for any number of reasons. We're trying to go and make sure that appropriate health and care are delivered to an individual. We're trying to make sure that information that's important to understand as part of that care picture is available. We're trying to make sure that information that is necessary to go and pay for care is available. So there are any number of reasons why we want to go and share healthcare information among the appropriate set of individuals that have a need to know and deliver care for a particular patient. The other reason we want to go and deal with interoperability broadly is that interfaces are expensive, especially if there's no standard that is being followed. And quite honestly, even if there are standards that are being followed, certain types of standards are very expensive to implement. HL7 defines a set of international interoperability standards and has for about 20-odd years. In 2011, the board of HL7 noted that the requirements are increasing and the standards that were available just aren't meeting the needs. There's need for real-time access to information. There's need to go and have information available in workflows, in particular in clinical workflows. The type and amount of information is increasing dramatically. So the ability to go and support access to devices, to genomics information has become increasingly important, as has the ability to go and define standardized coded information for analytics, population health. And quite honestly, implementer expectations are changing and changing dramatically. It used to be that there was a small, very small group of people that understood how to implement specific older standards like HL7 V2 or X12. But now we have, because of the internet, a very large set of implementers that had knowledge of specific types of standards to implement for exchanges. So we can take a fresh look. So what are the benefits of FHIR? First of all, FHIR was based on standardized tooling that implementers are familiar with, on XML and JSON to represent the standard itself, on HTTP and RESTful exchanges, on using TLS and OAuth to go and secure exchanges and to provide for authorization services. These are standards that are being used throughout the internet. And it was time to go and adopt basic internet technologies. We needed to be able to predefine what we're calling resources. We'll have the definition in a little while. And APIs, application program interfaces. We need to have the ability to extend things so that we don't have to try to define the world for everyone. We can define core concepts, and then where it's appropriate, individual organizations or trading partners can extend that capability without breaking the standard. We needed to allow implementers to focus on, as it says here, implementing core functionality and then start to expand around that. We needed something that had extensive documentation and good examples of how to implement something, and reference server implementations where they could go and they could explore the ability to go and implement these standards and to be able to exchange information interoperably. We need the ability to have validation services, the ability to go and validate that that exchange is actually conformant to the standard, and do that without a lot of additional effort. In fact, do that while implementation guides are being designed, while they're creating a particular instance of a resource. The ability to go and do that so that we have comfort that the things that we're designing, implementing, and exchanging are meeting the standards. We need an active and supportive community. It's not sufficient to have a very small number of people able to go and implement a standard or even define a standard. It's important that we have a very broad set of supportive community services and individuals that have been trained. And we needed to have open source code libraries. We didn't need to have everybody have proprietary solutions that had to be purchased through expensive licenses. We need something that was open and available for the community as a whole. And it had to be mobile friendly. We're living in a mobile world. We count on our smartphones to give us access to information wherever we happen to be. And we needed to make sure that this capability existed in whatever was created as a standard. We also had to have the ability to have commercial viability in the applications that are created. The differentiation is not in the ability to define the underlying resources, but rather to go and create solutions using these standards for exchange. And remember, FHIR is a standard for exchange. It can also be used for internal representation, but it's being designed to exchange information between organizations and their implementation of servers. What are the benefits to clinicians? Well, if it's simple enough, they get to be involved in the design. Okay, what are the things that are important to them? What kind of elements are necessary? What are the code systems? We'll talk about those later that can represent that information. So we can start to deal with both the syntax and the semantics of the exchange. We have tooling available that makes it easy for people to go and understand it and implement it and update it and particularly design it. We have to be able to improve access to quality patient information that needs to be exchanged between members of a care team. We need greater choice and variety of applications that can support clinical workflows. It's not okay to just have one solution or one off-the-shelf, one EHR as determining everything that a provider can use. We need to open the door so that we can have others provide easy-to-use extensions to an EHR or to a payer system or to somebody else in the community that's providing a service. In particular, we need to increase the speed with which we do development. We can't wait years to go and have the next version of a technology available. It needs to be something that we can evolve on a very rapid and predictable pace. And we need to be able to support clinical decision support, for example, around immunization protocols, and we have to overall be able to save time by having standards that are easy to create, easy to understand, easy to adopt. What are the benefits to consumers? Increasing patient engagement by having applications that make sense for them to be able to use, accessing their data on clinical systems and quite honestly on payer systems and other systems that are holding their data. Allow them to engage more freely, to become part of the solution for, manage their own health and care. Giving them access to more complete patient records, making decisions jointly. Individuals specifying what matters to them, what are their goals, being able to more efficiently diagnose and treat. But overall, ability to provide improved patient experience and reduce wasted time. Benefits to healthcare organizations. The more vendors are committed to FHIR, the more easily we can exchange information between disparate organizations. Even within organizations, the ability to integrate and and provide solutions across different technology platforms improves. What does it lead to? As it says here, faster deployments, lower cost of interoperability, and reduced vendor lock-in. And the ability to go and provide enhanced capabilities through standardized APIs, using APIs to support internal application development, being able to go and express information that's in a proprietary platform in a standard way allows us to create integration environments within and between organizations that previously weren't possible. And the ability to capture data, as was here for analytics, decision support, and population management, all are important. FHIR adoption, this is an older picture. This is from 2019, and it actually is going back to 2015, looking at the number of institutions and clinicians that have access to EHRs that have certified for FHIR Release 2. And to keep in mind, this is the old DSTU2 that was released in 15, actually in 14, and its adoption by certified EHR platforms. So 87% of hospitals, 57% of clinicians at that point in time. What's important to remember is now with the new ONC final rule and CMS's final rule on interoperability, all certified EHRs are going to wind up supporting FHIR, and will have to do so by next year. So we will have a standard that is available to every clinician and every hospital that uses a certified EHR platform. And that will be FHIR R4. We've had another release in the middle, STU3. That did not get broadly adopted, but R4 is being written into regulation, both for providers, EHR certification, and for, quite honestly, payers. We're going to see support on the part of payers that have to provide a patient access API. So any payer that has services or plans for Medicare Advantage, for Medicaid, for CHIP, for QHP in the federal marketplace are all going to have to support directly or through one of their partners the ability to access their information using FHIR R4, the same standard as required by certified EHRs. So we're seeing incredibly broad adoption of the standards, the FHIR standard. This is, I think he's using it. They have their FHIR endpoints that have been promoted. This is going back to some of the DSTU2. They have sandboxes available to go and develop things around their open APIs. We have Cerner doing exactly the same thing. These are just links to it. Microsoft, Amazon, Google, IBM, Oracle, Salesforce are all coming out and supporting FHIR as a way to organize and exchange healthcare information. We have Google Healthcare Cloud support. We also have it through Microsoft. We have, at this point, supporting health records on iPhones, 55 different institutions. At the time this slide was created, it's far more than that now, that are making their information available to the Apple health record or health kit. All right, that's kind of the background on why we did it and where it is. Now let's talk about what it is. So basics of FHIR. It was built around a FHIR manifesto. It was implementer focused, making it easy for organizations to implement. It's targeted on the 80%, the common stuff, okay? The expectation is that everything that's in a FHIR resource should be used by 80% of the people that implement it. It's not the exceptions, it's the rule. Extensions are used to define the exceptions, something special for this particular use case, something special for this particular trading partner exchange. It uses today's web technologies. It supports human readability. Everything is readable. The exchanges are readable, the instances are readable, etc. It's paradigm and architecturally agnostic. It doesn't really rely on a particular underlying modeling. And the source is open. Anyone can use it. There is no license fee. Okay, what does FHIR stand for? Took us a long time to get to that point. Fast Healthcare Interoperability Resources. These are consistent, simple to use content models. That's what a resource is. We'll give examples in a minute. They have very controlled extensibility process. So we can extend any of these resources. The resource, we'll talk about it right now, is perhaps patient demographics. But we can extend it. So we may extend it to provide access to and exchange of things like race and ethnicity, something that isn't required internationally, but may be required here in the U.S. And so that would become part of a U.S. standard profile for these extensions. Supports paradigms of exchange, real-time APIs. We've had lots of exchanges in the past that weren't necessarily real-time and certainly weren't necessarily integrated into clinical workflow. It also supports documents and messaging and operations. We'll talk about those. Again, designed with the implementer in mind. Freely available, detailed online hyperlink specifications, unlike the tomes that we would get with prior standards, where you print off 300 pages and put it into a large 3-ring binder and have to flip through it and know where things were, put in little sticky notes to go and indicate, look here to find the answer to a problem. Now it's all online, all hyperlinked. Freely available tooling and servers and libraries, as we mentioned before. That's what we built around. So these are out there, they're available. You can download them, use them. They're not proprietary, and they don't require fees to use. We have very strong support from vendors, providers, and regulatory community, as evidenced by the most recent regulations that require it. And we have a massive international supporting community. So how's it related to other healthcare standards? Well, we have HL7v2, used very broadly for things like ADT transactions, used to order lab tests, used to report lab results back. We have version 3, which is basically built around the idea of instead of a fixed positionally fixed standard like version 2, delimited standard. Now we have something that's focused on XML. That led to consolidated, the CDA, the consolidated data architecture, which ultimately is a consolidated, CDA, and then the consolidated clinical data architecture. We've been using CCDA for a while to exchange summaries of information between organizations. While it's been successful, it is also difficult to use. It also has a number of drawbacks, and it certainly is focused around exchanging more information than may be necessary in a particular context. We have other ones, Open EHR, Clinical Information Model Initiatives, IHE, Integrating the Healthcare Enterprise, DICOM, focused around exchanging digital images. And then we have a series of terminologies we'll talk about later, like SNOMED and ICD. Here's a timeline. 2010, HL7 Task Force was created to get a fresh look at where standard should go. Jason Task Force in 2014 and the Argonaut Project focused around FHIR as a standard. We had the open API requirements in 2015. Apple built their iOS and FHIR integration environment in 18. The Da Vinci project started to address interoperability for value-based care in 18. We had cloud vendors commit to FHIR. We had FHIR R4 come out as a standard in December of 2018. And then in March of 2019, we had CMS and ONC put out a notice of proposed rulemaking that ultimately became a final rule in May of 2020. And that's the rule I've been referring to that requires EHR vendors or certified platforms to adopt FHIR R4, and CMS requiring payers that support the environments or the plans I mentioned, Medicare, managed care, Medicaid managed care, CHIP managed care, and QHP in the federal marketplace had to go and adopt FHIR R4 standards to make patient data available through a patient access API. Okay, why is it different from other standards? Well, it's focused on the implementers. It's focused on community involvement. It's tested at connectathons, what we're holding this week, getting people together to test the standard, to test the implementation guides, to make sure they work before we wind up introducing them broadly in the community. It's not just go out and find 4 or 5 implementers that want to do it. It's an open community that is focused on evolving and validating the FHIR standards and those things that are built on top of it. Test servers are available, open source libraries, and then free tooling like FHIR and Forge. Where can you use FHIR? You can use FHIR to go and front end other standards like V2 and V3. You can use FHIR to go and exchange information between EHRs or PHRs and applications. And you can use FHIR to expose through common APIs, databases that you wish to make accessible. So those can be EHR databases, they can be any kind of a database. What does the specification look like? Well, here's a picture of a very lightweight version of the specification. We'll actually go online and see the real thing at the end of this session. But it basically has foundational information, base documentation on XML, JSON, REST, etc. It has implementer support. It has privacy and security items. It has conformance standards, structured definitions. All the FHIR resources are built based on a structured definition. It has support for terminologies. It has linked data information. There are administrative resources, patient, practitioner, device, organization. There are clinical resources around allergies, problems, diagnostic resources, observations, etc. Medication, workflow, financial. So there's a whole series of resources. These names is a resource. It's a related set of information that are the building blocks of FHIR. So what are resources? They're content models. They're things that are exchanged. You can exchange them via REST, FHIR RESTful APIs, exchange them in messages, exchange them in documents. And by documents, I mean electronic documents, not paper-based documents or image documents. They're informed by past work. Took advantage of everything we had learned to date. Learned through using, creating, using, and deploying HL7 V2, V3, the RIM model, the reference implementation model, or information model, CDA, other standards that we mentioned before, all went into understanding how we can create resources that make sense. What are the resources? There are general resources like allergy intolerance, conditions or problems, or diagnoses, procedures, etc. There are care provisioning, a care plan, a care team, concept of a goal, a referral request. There are information around medications and immunizations, orders, administrations, dispense, medication statements, etc. And there are diagnostic resources around observations, diagnostic reports, diagnostic orders, etc. So these are all different resources. What's inside of a resource? Well, it has a identity and metadata associated with it. So it names what it is. It names other things related to it. For example, what profile it may be based on. It has a human readable summary. Okay. It also has a definition of extensions that may be applied to it to extend its capability. So it may have an extension, for example, around consent to do a trial in this case. And it has a standard set of data defined as either XML or JSON. Resources reference each other. That's how we create an information model. So, for example, a procedure resource, which defines what happened in a procedure, references a subject, the patient, references a related item, a condition. So this could be the diagnosis. It references a report, a diagnostic report. It references a performer, a practitioner. It references an encounter. Okay? So all of these things are linked together through references to other resources from the procedure resource. And this is how all of these are modeled. All the resources are modeled with references to other resources. And so together they create an information statement or an information structure. So if we look at recording a consultation, so we have a 12-year-old boy complaining of pain in the right ear for 3 days. Well, that's a condition. With an elevated temperature, that's an observation. On examination, temperature 38 degrees, again, an observation. And inflamed right eardrum, again, observation. With no perforation, the diagnosis is otitis media, that's a condition. And we prescribed amoxicillin, 250 milligrams, 3 times a day for 7 days. That's a medication. Follow-up consultation 2 days later, returned with an itchy skin rash, that's a condition. Had no breathing difficulties, that's also a condition. On examination, euthychroral rash, that's an observation on both arms. No evidence of meningitis, diagnosis of penicillin allergy, that's an allergy intolerance. Antibiotics changed to erythromycin, 250 milligrams, 4 times a day for 10 days, that's a medication. So we can take a typical recorded consultation and we can represent all of its key components as various FHIR resources. And here we go and show how they relate to link to each other. So for each of these items, there's an asserter. There's a performer. So the asserter can be the patient. They asserted that that's what happened. The practitioner can also be the performer of recording information, or the asserter. We have encounters. We had 2 different encounters described on the previous clinical scenario. So this is how they all link together to basically define the information that we described in that encounter, or those 2 encounters. Structured and coded data. We've discussed structure of information. That's what a resource is, structure of the information. Coding the information is a separate step or separate process. It is the semantics of what we're talking about, not the structure anymore, but the semantics. And why do we use it? Well, it improves UI possibilities. It improves the exchange quality. It provides for secondary uses such as clinical decision support and population health. Here's an example of a resource itself, and we'll see these kind of definitions. You'll see them in the implementation guides we've created. You'll see them on the FHIR site, and we'll walk through a couple of them. This is what a resource looks like internally. So this is a patient resource. Okay, information about an individual or can be an animal. Be used for more than just individuals. Receiving healthcare services. There are a set of metadata associated with that, with every resource, such as its ID. This would be the unique ID of an instance. Metadata that maybe defines which profile was used. We'll talk about profiles in a minute. Implicit rules, language, text, etc. There's an identifier. These are identifiers, and we have some structure here we'll talk about. This is the name of an element. This is the type of the element. This is the cardinality of the element. Cardinality basically says how many times can this occur. 0 to star says it doesn't have to be there, and it can occur an unlimited number of times. 0 to 1 says it doesn't have to be there, but it can only occur once if it occurs at all. There may be some down here that are constrained 1 to 1, which says it must be there and can only be there once. So cardinality basically says how many times can that element be part of that instance of the resource. The type is actually tells you what type of information is. It's an identifier, and the definition is behind identifier. It's a Boolean, okay? It can only be true or false. It's a human name, and human name can be is a complex type. So it defines everything that's necessary to describe a human name. First name, middle initial, last name. There may be other things that go with it. A contact point, it describes all the information necessary to describe contacting an individual relevant to that particular person. It also can be a phone number or a fax, etc. Gender is a code. We talked about coded information. Well, in this case, the code is limited to male, female, and other or unknown. Okay, that has been expanded for us, and has been expanded very recently for some of the other issues related to gender. Birth date is the date of the birth of the individual, so it's a date type. Deceased, if they're deceased, so it's a Boolean yes or no, and the date and time they were deceased. Address, so this is a complex data element describing the address of an individual. So it can be, you know, the street address, the street, the city, the state, the zip code, geolocation information if appropriate, and they can have more than one address. Marital status, multiple birth information, photos as an attachment, etc. So this is what a resource structure looks like. Now, coded information, gender is coded. Okay. We have a codable concept around marital status. A codable concept is an interesting construct. It allows you to go and define a code from a value set that comes from a terminology system. We'll talk about that in a little while. And a codable concepts allow you to have more than one code that's an equivalent. So I could have a SNOMED CT code that is the equivalent to an ICD-10 code, and that would be allowed in a codable concept. And down here we have another one on contact role. So we have ways of expressing not just the structure and not just how the structure itself is identified, meaning what type, but also codes that are necessary to go and make sure we understand the semantics of that element. Okay, we have a terminology subsystem in FHIR. It understands a whole host of different terminology systems, code systems. And these, for example, SNOMED CT would be a code system. LOINC is a code system. RxNorm is a code system describing medications. This in general describes observations. This in general describes clinical observations. ICD-10, 9 and 10. describing a particular diagnosis. Drug formularies. Those formularies may well use RxNorm or may use NDC. And then other custom ones. And there are lots and lots and lots of custom code systems. So when we want to define a code or a coding, which is a single, not a single code, but a code from a terminology or code system, it is not a codable concept. It doesn't allow you to have equivalents. Codable concepts can have multiple codings. Codings can have multiple codes. What we do is we conform to a definition for a value set reference based on element type. We refer to a code system. So it has to be a code from a code system. So this may be a particular SNOMED CT code that conforms to an element requirement. And those bind to a value set. And those value sets are selected from that code system. So ultimately, what we do for a large part of the semantics in FHIR is to refer to a value set for a particular element. So that may be a value set that defines values that are appropriate for a particular type of lab test that comes back as something other than a numeric value. So we use this broadly. We will find the need for terminologies everywhere in FHIR. Profiling.
Bob, sorry, it's Evelyn.
Yep.
Just before you jump into profiling, because I know the value set work is really important. So I just want to pause and see if there's any questions. I'm not seeing any on the chat, but I know this is a lot of information. So just want to double check if anyone on the call has any questions before Bob jumps into profiling. Okay.
And you are drinking from a fire hose.
Yes.
Unintended.
I know.
Okay.
We appreciate it, Bob. All right. Don't be shy to ask questions. And I know some of you have asked, we'll have the recording available, but yes, please let us know if we can clarify anything else. Thank you. Go ahead, Bob.
Okay. Thank you for pausing me. We saw an example back here of a typical resource. And remember, that resource has a set of cardinalities. It has a set of value sets. Required says you have to have one of these. Extensible says, well, if one of these works, you have to have it. But if it doesn't work, you can extend it. There could be value sets that are examples. Okay, in other words, we're not requiring you to do anything particular. Here's an example of what you might do. We have cardinalities that basically are as open as possible. Well, gender, you should only have one gender. Birth date, you can really only have one birth date. Or you might not know any. It might be 0 to 1. But with names, you can have more than one name. You can have more than one identifier. You can have more than one address. And there's a construct down here called the backbone element, which has basically repeats itself, so contact information can repeat.
Bob, there's a question. There's a question from Jill asking whether for the resource structure, there are planned updates to some of the terminology, gender as an example.
I'm sorry, say it again.
There's a question in the chat from Jill whether there are planned updates to terminology, for example, gender having more than other.
Yeah, there was a task force that was put together at HL7 to address some of the gender identity issues. They have published some results. What's on here is I don't know if it's being updated as an update to gender or it is an extension to address that. It might be either one, I don't remember. But yes, there's work that's been done on gender. There's work that's been done on race and ethnicity. There's work that's being done to be able to represent those in FHIR resources. And when we get to the point where we're able to look at the actual site itself, I'll try to remember to walk you through some of that if we have the time. Okay. So while this is great for a general structure, it doesn't necessarily meet the requirements of a particular use case. For example, I may have a use case where I only want one human name. Sorry, I don't want any more. I may have a use case where I require a gender. You have to pick from one of these. You can't leave it blank, conceptually. By the way, blank just means that element doesn't appear. You have to have a birth date or I can't deal with it. Okay? To do that and to link in things like race and ethnicity, which are extensions, I have to have what's called a profile. And what that profile does is it allows me to set the context around a particular use case. It describes the usage of a FHIR resource based on that context. It allows me to do things like particular validation requirements, particular code requirements. So it constrains a resource by removing elements. There may be elements that don't make any sense whatsoever. For example, social determinants of health information around a body site doesn't make sense. So you would remove body site from a particular resource by changing its cardinality to 0 to 0. You don't just take it out. You basically say there shouldn't be any of these. Change the multiplicity. So, for example, I might have something that's 0 to star. Well, I'm sorry, it's 1 to 2. You have to have at least 1, and the most you can have are 2. Or fixing values. We may actually say that for this particular element, the only value that's valid is this one. Changing coded elements and doing bindings. So binding particular value sets that say, here, this is the list of acceptable values. That's it. There's nothing else we allow. That would be a required value set. And as we said, adding extensions. We do all these through profiling. So we can limit the name to just 1 instead of 0 to star. We can require a particular type of identifier. So, for example, for a provider, we require them to have an NPI. We may say, well, we don't want to support a photo for this particular use. And we may want to add an extension. So these are all things that we do by profiling. And you'll see profiles in our implementation guides, and we'll go through them on Thursday. All right, let's talk about exchange paradigms. We've talked about how to go and structure information. We've talked about how to specify the semantics of that information, not how to exchange it. Well, we have 4 basic ways we can exchange FHIR. We can do it through RESTful interactions. We can do it through, and this is what most of the internet uses. We can do it through messages. These are asynchronous things that can be used. We could even use direct as a messaging exchange method. We can do it by exchanging documents. Now, these are not documents, meaning paper. They're not PDFs, but they are FHIR structured documents that pull together a set of information. And then we can do it by having operations that we define, services, things that are too complex to just do through RESTful operations. We define services. So, for example, processing a message would be a service. We have things called bundles. We seldom look at just a single FHIR resource. We can, but we seldom do that. If you remember back when we showed the relationships between various FHIR resources, typically we will have a bundle that will have a whole series of things in it. It'll have the patient identifier, it'll have a provider identifier, it'll have an organization, it'll have a location, it'll have observations, it will have condition resources. Those will all be in something called a bundle resource, which wraps it. There are several types of bundles. You can have a search set. So I went out and I did a search and returned all those. Well, that would be a search set bundle. It's a transaction. I need all of these to specify a particular transaction, otherwise I can't do it. It's all part of a document, and we'll show an example of that in a minute, or a message. So these are all bundle resources that basically take base resources and assemble them together in a bundle for exchange. RESTful APIs. REST is representational state transfer. It's an architecture for how to exchange information in real time. It uses HTTPS. It is quite simple to use. It has only 4 verbs. I can create, I can read, I can update, and I can delete. And that is all I can do. Okay, but those are incredibly powerful verbs. It is commonly used outside of healthcare. Almost everything you see on the internet uses RESTful exchanges. And that's one of the reasons why we support it. And the real important part is it can be used in real time, and there's a lot of support around it to do security and authentication authorization. Where have you used it? You use it every time you use Yelp. You use it every time you use Expedia. You use it every time you use basically any of the normal services that you're using on the internet. If you go on to Amazon, you're using it to go and access information from the various servers they link to. If you're using it with Google to look something up, you're using it there. Virtually everything we do on the internet uses REST. Okay. We have document paradigms. I think how much more time do we have? We're kind of tight. Okay, document paradigm allows us to go in, for example, take a CDA, a clinical document architecture, and do it in FHIR. It has a structure that we build off of. So, for example, it's a bundle. It has a composition resource. It can contain a set of observations, devices, list resources, etc. Messaging paradigm, the ability to go and do a notification or instruction, the ability to go and exchange information asynchronously is a messaging paradigm. And messages are also bundles. They have a message header, they have observations, etc. So it's a linked set of it. Virtually everything we exchange, with rare exception, is a bundle. We seldom take resources out of context. Services operations are for more complex things. Clinical decision support, specifying immunization protocols, etc. These are complex operations that require something more than the 4 verbs that are available through REST. Now, we will use REST to go and push a bundle to a particular operation, but the operation is much more complex than just being able to go and save the information or retrieve information. It does complex processing as part of it, or can. So FHIR operations, we need more than CRUD. We know the RESTful verbs. And then finally, I think we have it down here, regardless of the paradigm, the content's the same. It doesn't matter if you're using REST or you're using a document, or you're using messaging, or you're using an operation. The content is always the same. We have the same way of expressing a patient. We have the same way of expressing terminology associated with it. We have a couple of minutes left. I'm going to do a link over here to the site. If you want to go to it, hl7.org/FHIR will take you there. Let me see if I can open this up. Open the link. And this takes us to the FHIR documentation. This is for release 4. When you come in here, you can pick a directory of published versions. You can go to any of the releases. We're working on release 5 right now. There's also release 3. STU3. And if you want to go back and look at the draft standard for trial use 2, one we talked about, they're all here. So I'm going to go and stop here. Well, I'll do one more thing. Across the top are documentation, the list of the resources, profiles on resources, extensions, which we talked about, operations, we talked about, and terminology. So from here, you can drive into almost anything. If we go into resources, for example, you have, and I'll give you an alphabetical list of all the different resources. We talked and showed a patient resource, which would be here. And this is the structure of a patient resource. And these are the things that we had shown before. The identification of an element, cardinality, and type. And all of these, everything that is blue is a hyperlink, and you can get more information on it. I'm going to stop at this point and see if we have any other questions that we want to entertain in the last 4 minutes.
Bob, there's a question from Aaron. Are there differences between REST-based IGs and message IGs?
Repeat that again. I missed something.
Are there differences between REST-based IGs and message IGs? And Aaron, if you're on, please chime in.
And message-based IGs?
Message.
Yeah, I'm just curious, when you write an implementation guide for a message-based exchange.
Message.
Yeah, message, M-E-S-S-A-G, sorry.
In the way you specify the resources, in the way you specify the profiles, in the way you specify the value sets and extensions, no, they're absolutely identical. In the way you specify workflow, yes, they're different. And you may only do certain types of things. So for example, if I want to go and exchange a service request with another organization, and I want to do it based on a task and a RESTful exchange, I will incorporate that. But I could just as easily turn around and say, and you can do this using a message, or you could do this by sending it against as a bundle against an operation endpoint. So the way I specify the content, the semantics, and the structure and the semantics are identical. The way I specify the workflow interaction is quite different depending upon the operation type I want to do. But I can put them all in one implementation guide.
Okay, good. Thank you, Bob.
Okay. And I can put them in different implementation guides. It just depends upon what you want to do. I would argue if you're exchanging the same information and using different workflow types, then you probably would want to put them in a single implementation guide so you don't confuse people. Okay, other questions? Okay, I'm not hearing any. So let me do one more thing before we end. Let's say, for example, you want to look at terminologies. These are code systems. Well, what are the code systems? Here's a list of them. SNOMED is here. LOINC is here. NDC codes are here. CVX. These are all code systems, and they have references to the code systems. You can also look at value sets. These are value sets that have been defined from code systems. So these are action types. A lot of these have the code system and the value sets are almost identical. For example, here, administration method codes comes from SNOMED CT. So this is a complete list of what FHIR supports today, at least in R4. You can look at where we're headed by looking at the R5, which is in ballot and will be released sometime next year as a full final release. Okay, I think that's everything. Evelyn, anything else we should do before we adjourn for today?
No, that's great. I want to encourage everyone, if they do have questions, and Bob, we can send an email with the slide deck on it. Just to reach back to us, and please join us for the Thursday session. Just encourage
Okay.
everyone to do so. Thank you, Bob.
Obviously, this is a very high level. If you're
Yeah.
interested in further education in FHIR, there HL7 has any number of classes you can take. Some of them are self-tutorial classes. You get the material and go through them. Others are ones where we have a moderator or an instructor that can walk you through it. So feel free to take those classes. They are of incredible value. And at the beginning of every Connectathon, we typically have education sessions that can help people understand more details around FHIR and its applications. So I want to thank everyone for joining today and wish you a fantastic week. We look forward to talking to you again on Thursday morning, and we'll go through the FHIR SDOH implementation guide. Thank you.
Thanks.